Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble code P0223, indicating a high voltage condition in the TP Throttle Position Sensor B circuit for the Honda Accord models from 2012 to 2017. The TP Sensor B is a vital component of the vehicle's throttle body system, as it communicates with the Engine Control Module, ECM, to provide real-time data on throttle position. This data is essential for optimal engine performance and fuel efficiency. The TP Sensor B's location is typically near the throttle body itself, usually in close proximity to TP Sensor A. When the P0223 code is triggered, it means that the voltage reading from Sensor B has reached levels greater than what is acceptable, leading to potential performance issues. Addressing this code is crucial for maintaining engine operation, as it may affect acceleration response and overall drivability. Finalizing the troubleshooting process for DTC P0223, the technician must ensure everything is correctly reassembled. Start by turning the ignition switch to the off position and systematically reconnect all disconnected connectors, making sure to secure each connection properly. Exit the SCS mode with the HDS to restore normal operation parameters. Once all parts are restored, the ignition should be turned back on to ensure systems initialize properly. The PCM then requires resetting, which reestablishes its baseline parameters. Completing the PCM idle learn procedure is crucial, as it allows the computer to relearn the throttle body's position and its behavior. Finally, a check for any pending or confirmed DTCs should be performed to confirm that P0223 is no longer indicated, ensuring the integrity of the repair work and system functionality. In terms of preventive maintenance for addressing issues related to DTC P0223, several proactive strategies can enhance the reliability of the throttle position sensors. Regular inspections of the throttle position sensors can catch potential failures before they result in drivetrain issues. It is extremely beneficial to routinely check wiring connections and related components, since loose or corroded terminals often lead to intermittent faults. Keeping the PCM software up to date is vital. Software updates can rectify bugs that affect sensor readings. Routine diagnostic checks would help identify problems early, and keeping a habit of clearing fault codes post-maintenance can help ensure the diagnostic system remains clear of unnecessary alerts. Implementing these preventive measures can promote vehicle health and enhance reliability over time. In conclusion, addressing DTC P0223 requires an understanding of its symptoms and causes, along with executing a structured troubleshooting process. The thorough evaluation, from checking voltage signals to examining wiring integrity, directly contributes to successfully diagnosing and rectifying the issue. Verification of repairs made is equally crucial, ensuring that the system is operational and has no leftover fault codes. Moreover, implementing preventive maintenance strategies can significantly reduce the likelihood of future occurrences of similar codes. Finally, prioritizing regular diagnostics keeps vehicle systems in optimal working conditions and assures effective responsiveness of the throttle by maintaining the integrity of the connection between the TP sensors and the PCM. The DTC P0223 specifically refers to an issue with TP Sensor B, which is critical in relaying the throttle position information to the Powertrain Control Module, PCM. This sensor is integral because it helps manage the vehicle's air-fuel mixture and promotes efficient engine performance. Typically located directly on the throttle body, the sensors work in conjunction with each other to provide accurate readings. In this fault scenario, the issue arises when the voltage signal from TP sensor B exceeds 4.8 volts, signifying a high voltage condition. This reading can significantly impact engine operation, including the throttle response, and potentially lead to a reduction in vehicle performance if not addressed promptly. Using a diagnostic tool, such as the Honda Diagnostic System, HDS, mechanical issues in this sensor circuit can be identified and resolved. There are several potential causes that could lead to a DTC P0223 condition. One common issue is an electrical short circuit in the wiring that connects TP sensor B to the PCM, which may cause an abnormal voltage reading. Another possibility is a malfunction or failure of TP sensor B itself, which might require replacement. Poor connections or loose terminals at junctions can also cause erratic signals. It's essential to inspect these thoroughly. Additionally, if there are issues with the PCM, such as corrupted software or hardware failures, they can impact the sensor readings as well. Proper diagnosis requires a systematic approach to check each of these components for faults to address the high voltage reading accurately. When facing a DTC P0223, drivers may notice various symptoms indicating an issue with the throttle position sensor circuit. One of the most prominent signs is reduced engine performance. The vehicle may struggle to accelerate or respond sluggishly. Additionally, there may be a noticeable delay in throttle response, which can affect overall drivability. The check engine light, CEL, is typically illuminated on the dashboard, signaling a need for diagnostic attention. Intermittent surging can occur, where the engine unexpectedly revs or fluctuates, impacting control while driving. Furthermore, poor fuel efficiency may result from the incorrect air-fuel mixture, a direct consequence of having faulty throttle sensor data. Recognizing these symptoms can prompt timely diagnostic procedures to rectify the underlying issues causing the DTC. The first step in troubleshooting DTC P0223 involves ensuring that the vehicle's ignition switch is in the on position, or by pressing the engine's start-stop button to select the on mode. Once this is confirmed, the next step is to clear the DTC using the Honda Diagnostic System. After clearing, it's essential to check the TP sensor B in the data list with the HDS to observe its voltage readings. The current condition should be verified. If the voltage exceeds 4.8 volts, it confirms the failure, and the technician can proceed to the next troubleshooting step. However, if the readings indicate that the signal is within normal limits, this indicates an intermittent fault, and attention should be directed toward potential poor connections or loose terminals at both the throttle body and PCM, warranting a thorough inspection. In this second troubleshooting step for DTC P0223, it is critical to check for any additional fault codes present in the system with the HDS. Confirm whether there are either pending or confirmed DTCs, specifically looking for DTC P0123, which indicates a high voltage in TP sensor A. The presence of both P0123 and P0223 would suggest a broader issue, possibly affecting the entire throttle body control system, requiring a targeted approach based on this finding. If both codes are confirmed, moving directly to step 5 of the troubleshooting process is advised. If not, and only P0223 is indicated, the technician should proceed with the next steps focused on the throttle body and its connections to the ECM. Step 3 in addressing the DTC P0223 requires the technician to first turn the ignition switch to the off position, and this includes using the engine start-stop button to ensure the system is inactive. Following this, the throttle body 6P connector should be disconnected to isolate the sensor. Once disconnected, the ignition can be turned back to on mode, ensuring that the system is primed for diagnostics. Next, it is crucial to measure the voltage between specific test points, one at the throttle body connector and the other at body ground. An ideal voltage reading should be about 5.0 volts. Achieving this indicates that the circuit is functioning correctly. If the voltage confirms this reading, it points towards needing to replace the throttle body, which would then require a thorough verification of the repair. If the reading is below or above that measurement, further investigation is necessary at the wiring or components. For the fourth troubleshooting step regarding DTC P0223, start by ensuring the ignition switch is off, followed by jumping the SCS, Service Connector Switch line, using the HDS. This action allows for proper testing of the circuit without interference. Next, disconnect the PCM connector B51P from the system, isolating the powertrain control module from possible faults. At this point, it is essential to check continuity by measuring between the previously specified test points. This includes the throttle body 6P connector and the discrete wires in the PCM connector. If continuity exists, the THL2 wire is verified as functional, allowing the technician to consider updating the PCM software. On the other hand, if no continuity is detected, the technician must locate and repair any open circuits in the THL2 wire between the PCM and throttle body before proceeding with further testing. The final troubleshooting step is critical for understanding the SG3 dBW line, which might be integral to the functionality of the throttle system. Begin by ensuring the ignition switch is turned off, similar to previous steps, and jump the SCS line using the HDS for proper testing. Disconnect both the PCM connector B51P and the throttle body 6P connector to isolate the circuits. Continuity between the throttle body connector and the PCM connector should be tested at the specified points designed for the SG3 wiring. A successful continuity check indicates there are no faults in the SG3 wire, and the technician should then consider updating the PCM software or substituting it wholly if functionality is called into question. Conversely, if the continuity fails, there's a clear need for the technician to repair any breaks in the SG3 wire before completing the necessary verifications. Please like and subscribe to the channel. See you next time.